Look closely at this dark, viscous polymer. Those black specks are the physical signs of degraded silicone, EPDM, and flexible elastomers. These materials do not tolerate processing mistakes. When operators treat these elastomers like rigid plastics, the first instinct is often to increase the heat. But instead of melting the residue away, the excess temperature carbonizes it. Low-temperature mechanical purging solves this by dropping the heat and relying entirely on physical friction. It clears the barrel completely without requiring a manual screw pull. Before starting, verify 3 things. The machine must be stable at its normal operating temperature. You need a dedicated low-temperature mechanical purge like PEKUTHERM ULT, and your next production material must be ready. Getting this set up right turns a process that usually causes hours of scrap and downtime into a standard, predictable changeover. Step 1. Check your control panel and lock in the current, safe processing temperature for your specific flexible material. On this control panel graph, the temperature line remains flat. Do not spike the heat to force the material out faster. If the temperature exceeds the material's tolerance, the elastomer burns and bakes a hard layer of carbon directly onto the metal surfaces of the barrel. With the temperature stabilized, load your low-temperature mechanical purge straight into the hopper. Inside the barrel, this purge behaves differently. Instead of melting, the solid pellets compress into a thick thermoelastic mass. Moving forward, it acts as a physical scrubber, catching baked-on carbon and scraping residue off the screw flights. This physical scrubbing action removes contamination without the thermal risks associated with a traditional chemical melt. Step 2. Feed the purge continuously so it moves through the machine as an unbroken plug. There are 2 specific errors to avoid. First, never mix or dilute a mechanical purge with carrier resin. Dilution spreads contamination rather than removing it. Second, do not let the purge soak in the barrel. Mechanical purges require constant forward physical movement to maintain their scrubbing friction. Watch the material exiting the nozzle. You are looking for the active transition from the contaminated run to the pure purge compound. Those thick, dark streaks in the stream are the encapsulated carbon deposits and burnt elastomer being physically pulled out of the machine. Once that output stops streaking and holds a uniform color, the contamination has been successfully removed. Maintaining steady forward pressure ensures the degraded residue is fully evicted out the nozzle, rather than just shifting into a different zone inside the barrel. Step 3. The moment your purge output runs clean, load your next production material into the hopper immediately. Because this method uses no carrier resin, there is no leftover liquid film inside the machine to dilute the incoming run. The incoming production material easily and completely displaces the solid, thermoelastic purge plug. Warning tone: if you find yourself running massive volumes of new material just to achieve a clear part, the initial purge was not executed correctly. An immediate, clean transition proves the barrel is decontaminated and ready for production. This is the goal: a machine running at full speed, producing flawless, uncontaminated parts. The black specks and burnt elastomer material have been eliminated without ever pulling the screw. This approach directly reduces scrap rates, eliminates burn-off contamination, and significantly speeds up changeovers. It also eliminates the downtime and heavy labor required for manual screw cleaning. For technical specifications on PEKUTHERM ULT or deep dive troubleshooting guides, follow the links in the description below. Successful material transitions come from controlling the machine with precise mechanical action rather than forcing it with heat.